Okay, so I'm going to do these in real time. I'm only going to do, there's 3 or 4 problems that you guys had trouble with, so those are the ones I'm going to do. So this is, first of all, 1c. dy dx equals x times y minus 1 quantity squared. And you were to find the general solution for this. So we know the only process we've done is separation of variables. And I told you the most important step was separating the variables correctly. So let's see if I can do that. It's going to be y minus 1 to the negative 2 dy equals x dx. And then what I need to do is I need to integrate both sides. I'm not getting fancy here. This is a simple power rule for both of these. So this is going to be y minus 1 to the negative 1, because negative 2 plus 1 is negative 1, not negative 3, contrary to popular belief, equals x squared over 2 plus c. And I need that plus c. Now the job is to solve for, now, most of you got here. I'm glad. However, 30 of you were unable to actually correctly solve this for y. Now, I don't think it's that complicated, but then, again, I'm a math teacher. I didn't think it was that complicated when I was a student either. But I'm going to, first of all, multiply both sides by negative 1. I'm going to rewrite this. I'm going to get 1 over y minus 1 equals negative 1/2 x squared. I'm going to put plus c1 because that c1 is different than that c. Now I'm going to take the reciprocal of both sides, and here's where some of you don't really understand how numbers work. And you know what? I don't know. I could teach this if you want me to. I can. In fact, I will talk about it in class. But when I take the reciprocal of this side right here, when I take the reciprocal of that, I get y minus 1. When I take the reciprocal of the other side, I don't get negative 2 over x squared plus a new constant. That's ridiculous. That doesn't even make any sense. What I get is 1 over negative 1/2 x squared plus c1. And then all I have to do is add 1 to both sides. So y equals 1 over negative 1/2 x squared plus c1 plus 1. It wasn't that hard. Okay? Not that complicated. Now, I do need to find c1 for the next part of the problem. The next part of the problem says that, let me go back to black here. For part D, it says that f of 1 equals 3, or was it f of 3 equals 1? Can't read it. F of 1 equals 3. So that means if x is 1, y is 3. If x is 1, y is 3. Now I'm going to go back to this right here and find that, since that c1 didn't change. So 1 over 3 minus 1, I put 3 in for y, when x is 1, 1 squared is 1, I don't have to worry about that, negative 1/2 plus c1, so c1 is equal to 1/2 plus 1/2, which, as far as I know, is equal to 1 still. So now my final answer is f of x, or y, or whatever you want to call it, is equal to 1 plus 1 over negative 1/2 x squared plus 1. I'm not going to get fancy. That's the end of it. That was not that hard of a question. Okay. Now, I didn't take off that many points. In fact, only 1 for what's called a gross conceptual error. And that is, I don't even want to talk about it. It's so embarrassing. I can't even talk about it. I'm sure you probably know what it is. So what I was looking for here, I was looking for separation of variables. If you did not separate the variables, you got everything wrong. I didn't give you any points if you didn't separate the variables. Because there's no way for you to solve it without separating the variables. Okay. Let's see. Then you got a point for separating the variables correctly. Some of you tried but didn't succeed. You got a point for the correct antiderivatives. That was 2 points. You got a point for a plus C, I think, and then a point for solving. It wasn't that hard. And then D, you got 2 points, one for using the initial conditions and one actually using them correctly. Okay, let's go to the next question. How's that? Okay, here's our next question. This was a little bit of a challenge. On the bright side, almost all of you started correctly. Okay, well, I'm sure there's alternate ways of doing this, but the easiest way, of course, is to choose u equals inverse tangent of x, and dv is equal to x squared dx. So du is equal to 1 over 1 plus x squared dx, and v is equal to x cubed over 3. So this is equal to uv, so this is going to be 1/3 x cubed inverse tangent of x, uv minus the integral of v du. So that's 1/3 x cubed, and then times 1 over 1 plus x squared dx. Now, on the upside, almost all of you got here. Some of you just decided to stop because you thought it was too hard. Some of you at least attempted to do this. So if you got to this point, the most I should have taken off is 2 points. You had to get here. Okay, and then there's a 4-point problem. Okay. Now, the question is, how do you find that antiderivative? So I'm just going to work with that part. I'm not going to work with the minus. I'm just going to work with that part that I've underlined in red. And then I'll trust that you could actually go ahead and plug it back in. So let's look at 1/3 integral of x cubed over x squared plus 1 dx. Now, there's actually a couple ways. There's 3 ways to go about doing this problem. They're all 3 on the blackboard, or on the whiteboard, in the back whiteboard. I'm going to do it here the way I did it, which is the way I would have expected you to do it, since it's the way I did most of them in class. U substitution. Now, if you remember, I talked about, if you're ever going to run into a polynomial where the degree of the numerator is higher than the degree of the denominator, the first thing you do is long division. And that is the easiest way to do it. But I'm going to do it the way that I would have expected you to do it, which was basically to choose u equals x squared plus 1. Some of you also use my trick of adding 0. I wouldn't have thought of doing that, but it did work out nicely. But I guess I'll do it the way I would have expected you to. So du is equal to 2x dx. So I got 1/3 integral. Well, the x cubed I'm going to think of as x times x squared. So I'm going to, and x squared is equal to u minus 1. So this is x times x squared, and x squared is u minus 1. So I've got the x squared taken care of. Now I get the x taken care of. Well, I'm going to put a 2 and a 1/2. And so what I've just done is I've just created a, well, actually, I'm not going to do it that way because that'll confuse you guys. Let me solve it for dx. So dx is equal to du over 2x. That was the other method, so I think you guys are going to find that easier. So I'm going to leave that x alone, and then denominator have u, and then dx is du over 2x. I think you guys will like that better. So my x's go away, so I have 1/6 integral of u minus 1 over u du. Well, that's just equal to 1/6 integral of 1. Some of you got there and it's like, don't know what to do now. Well, you're going to have to review your Algebra 1 skills. So that goes to there. And then this can come up here. That's 1/6 of u minus the ln of u. I don't need absolute values because u is x squared plus 1. And I got plus c. And so this is equal to 1/6. U was x squared plus 1 minus the ln of x squared plus 1 plus c. And then you just go ahead and put that in above. Now, this plus 1, as it turns out, is not necessary because it gets absorbed in the c. So if you do it a different way, you're not going to get that. That's not a big deal. Okay, for number 6, it was pretty much the entire thing. So we start with part A, which asks you to find d squared p dt squared in terms of p. Well, some of you have very little clue what the chain rule is, which is unfortunate. I suggest you learn it. So I'm going to write this as kp squared minus kcp. You guys have trouble dealing with what's called parameters, or letters that stand for constants. That's what algebra was about. Algebra was about bringing in variables and letters that stood for numbers. And that's kind of what separates the... Anyways, so the derivative of kp squared is 2kp dp dt minus kc dp dt. And so then if you, and then dp dt is up above. So that's going I'm going to factor that out. So it's going to be 2kp minus kc times dp dt, which is kp times p minus c. So that's the first part of part A. Find d squared in terms of p. Done. And then basically I asked you to show that dp dt was a maximum at c over 2. Well, honestly, all I was really looking for, this doesn't necessarily do it all, but what I was looking for is for you to set p double prime of t equal to 0. That was it. That was really all I wanted, and then solve it. So if you set that equal to 0, that's the above thing up there, by the way. So if I solve this equal to 0, you will in fact get p equals, well, you get several values, some that don't make any sense because of the given conditions. So the one value that you will get that makes sense is p equals c over 2. And you can do this many different ways, but if you wanted to talk about, this being a dp dt versus p being a parabola, opening down, because it's supposed to be c minus p, isn't it? Is that right? Oh, p minus c. Oh, k was okay. Well, k was negative, it turned out. So, anyways, you didn't really have to get into anything about that because it said p was between 0 and c, I think. Excuse me. So that's really all I was looking for. Now, here comes the next part. To solve it. Okay, again, this is exactly like one of the homework problems. The only difference is, instead of a K, I put a number there, and instead of a C, I put a number there. That's what was in the homework. So all I've done here is put in a letter instead of a number. That shouldn't really freak you out. Okay? I'm going to go through and solve this, and I talk about how, the efficient ways of solving this. So I've got to separate the variables. So this is part B we're on now. So let me change the color here, and I'll probably go on to the next page here too. I just want to separate the variables here. Excuse me. I'm going to leave the k alone. So I'm going to write it as dp over p times p minus c equals k dt. K dt. And then I'm going to integrate that. So let me go to the next page here. So we got, see if I can remember what I just wrote, dp over p times p minus c equals k dt. And then let's just find the antiderivative of this bad boy, and this one here. Now, you've done these in the homework, we've done them in class. I know where that's going to end up at. This is going to be a over p plus b over p minus c, dp, equals kt. Now some of you put a plus c here. Bad choice. C's already reserved. You put a plus c there and then you multiplied and got a c squared. Got to think when you're doing these. Sorry. Now this is, I'll find a and b later. So this is going to be a natural log of p, population is positive, plus b natural log of, now this is really going to, I'm going to need the absolute values here, p minus c, because of the nature of this problem, because it says what p is between 0 and c, kt plus c1. Now I'm going to go ahead and find A and B. So I know that A, let's see, A times P minus C plus B times P has got to equal 1. And so whether you use Horner's method or whatever, I don't care how you do it. I'm just going to do it the easier way. I know that A plus B must equal 0 because there's no P's on that side, and negative AC must equal 1. So A is equal to negative 1 over C, and B is the opposite of A, so B is equal to 1 over C. So now I can come over here. A is negative 1 over C, negative 1 over C ln of P, plus 1 over C ln of absolute value P minus C is equal to KT plus C1. I'm going to multiply both sides by negative C. So we got the ln of, that's supposed to be a P. I don't know why I wrote a B there. The ln of P minus the ln of the absolute value P minus C is equal to negative KT plus negative KT C, put this in the right order, negative, let me write it, negative CKT, and then that's just a constant, and that's a constant, so I'm just going to put a plus C2. Okay. Now I'm going to try and remember this for the next side. So we have the, let's see if I can remember that. So it's the ln of P minus the ln of the absolute value of P minus C is equal to negative CKT plus C2. I think that's what I had there. So this is the ln of the absolute value of P over P minus C equals negative CKT plus C2. I'm going to exponentiate both sides now. Here's where I got to be careful. P is less than C. P is between 0 and C. That was given the problem, which means the inside of this is actually going to be negative. So when I take the absolute value, it switches the signs. So this is going to become P over C minus P is equal to e to the negative CKT. And then if you remember, I'm going to put like a little C3 as a multiplier. Again, there's where some of you messed up. You got to learn how to work with exponents. And now I need to solve for P. So I'm going to take the reciprocal of each side. I don't care how you do this. I'm not going to judge you how you do this, but you got to be able to solve this for P. So C minus P over P. I flipped the left-hand side. I'm going to flip the right-hand side. So I'm going to take the reciprocal of C3, which I'm going to call C4. I'm going to take the reciprocal of the rest, so that's going to be an e to the CKT. Okay, now I can split this up. So now we got C over P minus 1 equals C4 e to the CKT. So C over P is equal to 1 plus C4 e to the CKT. I'm going to reciprocate both sides again. P over C is equal to 1 over 1 plus C4 e to the CKT. So I'm pretty good with my, what do you call those things? I don't know what I'm pretty good with. So P of T, my final answer, is equal to C over 1 plus C4 e to the CKT. Okay, now all I got to do is satisfy my initial conditions. Well, I know that, okay, so let me copy this. Oops. Now, granted, this was a little bit longer problem. Copy. Paste. Okay, so I know that P of 0 is equal to P naught. P of 0 equals P naught. So I know that C over 1 plus C4 equals P0. I'm going to try to solve for C4. So I'm going to flip both sides. So C4 plus 1 over C is equal to 1 over P sub 0. I think this is right. Multiply both sides by C. So multiply that side by C and that side by C, and that goes away with that. And then subtract 1. So C4 is equal to C over P naught minus 1. And that's it. So I'm all done. And then to find a P double prime as a function of T, quite honestly, some of you were smarter than I was. I went through and actually found the second derivative of this. It wasn't that bad. But some of you were smart enough to actually go back to the second derivative, right? Because we had P double prime from part A. From part A, we had P double prime as a function of P. As a function of P. And so all you did was you plugged P into that. And that's really all you had to do. Anyways, that's the end of it. Some people, the problems range, I'll talk about in a little class, they ranged from, some people did a problem in 5 minutes, while other people did the same problem. It took them an hour and a half. So I saw lots of mistakes, lots of very common mistakes. Going to have to get over those. You will have enough time to finish the AP exam. That's not a question. You will not have enough time to do a problem, or to do every problem incorrectly once and then correctly another time. That's not what you're going to be allotted. You will have enough time to do every problem right the first time. And you don't have to go super fast. You don't have to go super fast. Okay? But you can't go down the wrong path.